Good morning. Pag-usapan uli natin ngayon ang patungkol po sa gas fuel health hazard. Alam naman po nating lahat na ang dahilan po ng masama sa kalusugan ay ang carbon. Kaya po ang iba't ibang bansa gumawa ng mga hakbang para makontrol po ang carbon emission. Ngayon, liban pa po dyan sa carbon ay mayroon pa pong octane. Itong octane ay dinadagdag po ito sa gasoline para magkakaroon ng more efficient na combustion at para makontrol po yung pagkatok ng makina. Ang titingnan po natin sa animation, ganito po yung mangyayari dyan. During intake stroke, ang hangin, mixture po ng fuel ay pahatak po yung piston. Ngayon, pagkatapos po dyan, compression, makikita po natin na dahan-dahan pong pumupula or umiinit po yung hangin. Nakakasama po yung moisture. Ngayon, ang control po, ang function po ng octane ay para po makarating muna sa pinakamataas na level yung piston bago mag-spark. Kasi pag tumakbo na po ng matagal yung sasakyan, mainit na po itong paligid dito. Lahat dito sa loob ng combustion chamber ay mainit na po. Kaya po, pag kinompress po yung hangin, pwedeng hindi pa mag-spark yung spark plug ay magka-start na po yung combustion or yung mag-detonate na po yung mixture ng air fuel. Kaya po, dinadagdagan po ito ng octane para matagal po siyang mag-detonate. Talagang makarating muna sa pinakamataas yung piston at bago mag-spark yung spark plug. Sa ganon, tama po sa timing ang combustion sa loob ng makina. Ngayon po, ang masama po ngayon, ang itong octane na ito, dalawang dinalagay. Una, dito ay yung lead. Kaso lang, alam naman po natin na ang lead ay poisonous. Nakakamatay po ito pag marami pong content ng ma-inhale o mapasok sa katawan ng tao. At ang pangalawang panghalo sa octane ay ito pong bensin. Ang bensin naman po ay nagdudulot naman po ito ng leukemia. Napakatindi po. Parehas mga matinding sakit po ang naidudulot nito. Ngayon po, sa invention po na ginagamit po ang tubig or supplementing water into fuel. Kasi po ang tubig, alam naman po natin na minsan sinusulat po natin ito na H2O. So H is hydrogen and then yung O is oxygen. Na itong dalawa ay hindi po hazardous. Kaya ma-stabilize po pag mayroon pong tubig, hindi naman po tubig ang ini-inject natin kundi in the form of moisture. Actually, kasama lang pong ang moisture sa hydrogen dahil po atin pong kinakonvert muna ang water into hydrogen. Binabasag po natin itong H2O into hydrogen and oxygen. And then, sinasamahan po natin ito ng counting moisture para magkakaroon ng efficient combustion na kung saan ang function ng octane ay nagagawa ng moisture. Okay, so pakinggan natin sa pamagitan ng video ang explanation kung gaano ka tindi ang mga sakit na naidudulot nitong lead at saka itong bensin.
Hello, I'm Simon Whistler. You're watching the Today I Found Out YouTube channel, and in the video today we're looking at why lead used to be added to gasoline. Tetraethyl lead was used in early model cars to help reduce engine knocking, boost octane ratings, and help with wear and tear on valve sets within the motor. Due to concerns over air pollution and health risks, this type of gas was slowly phased out starting in the late 1970s and banned altogether in all on-road vehicles in the United States in 1995. For a more detailed explanation of why lead used to be added to gasoline, it's necessary to understand a little bit more about gasoline and what properties make it a good combustion material in car engines. Gasoline is a product of crude oil that is made of carbon atoms joined together into carbon chains. The different length of the chains creates different fuels. For example, methane has 1 carbon atom, propane has 3, and octane has 8 carbon atoms chained together. These chains have characteristics that behave differently under different circumstances. Characteristics like boiling point and ignition temperature, for instance, can vary greatly between them. As fuel is compressed in a motor's cylinder, it heats up. Should the fuel reach its ignition temperature during compression, it will auto-ignite at the wrong time. This causes loss of power and damage to the engine. Fuels such as heptane, which has 7 carbon atoms chained together, can ignite under very little compression. Octane, however, tends to handle compression extremely well. The higher the compression in the cylinders a car's motor can produce, the greater the power it can get out of each stroke of the piston. This makes it necessary to have fuels that can handle higher compression without auto-igniting. The higher the octane rating, the more compression the fuel can handle. An octane rating of 87 means that the fuel is a mixture of 87% octane and 13% heptane, or any mixture of fuels or additives that have the same performance of 87 to 13. In 1919, Dayton Metal Products Co. merged with General Motors. They formed a research division that set out to solve 2 problems: the need for high compression engines and the insufficient supply of fuel that would run them. On December 9, 1921, chemists led by Charles F. Kettering and his assistants Thomas Midgley and T.A. Boyd added tetraethyl lead to the fuel in a laboratory engine. The ever-present knock caused by auto-ignition of fuel being compressed past its ignition temperature was completely silenced. Most all automobiles at that time were subject to this engine knock, so the research team was overjoyed. Over time, other manufacturers found that by adding lead to fuel, they could significantly improve the octane rating of the gas. This allowed them to produce much cheaper grades of fuel and still maintain the needed octane ratings that a car's engine required. Another benefit that became known over time was that tetraethyl lead kept valve seats from becoming worn down prematurely. Exhaust valves in early model cars that were subject to engine knocking tended to get micro welds that would get pulled apart on opening. This resulted in rough valve seats and premature failure. Lead helped fuel ignite only when appropriate on the power stroke, thus helping eliminate exhaust valve wear and tear. The potential health issues with tetraethyl lead were known even before major oil companies began using it. In 1922, when plans for production of leaded gasoline were just getting underway, Thomas Midgley received a letter from Charles Claus, a German scientist, stating of lead, "It's a creeping and malicious poison," and warned that it had killed a fellow scientist. This didn't seem to faze Midgley, who himself had come down with lead poisoning during the planning phase. While recovering in Miami, Midgley wrote to an oil industry engineer that public poisoning was almost impossible, as no one will repeatedly get their hands covered in gasoline containing lead. Other opposition to lead came from a lab director for the Public Health Service, a part of the US Department of Health and Human Services, who wrote to the Assistant Surgeon General stating that lead was a serious menace to public health.
So, natutuklasan na nila dati pa man na ang lead ay talaga pong matindi, nakakamatay. Kaya po, pag bumili po tayo kung magpapakarga po tayo ng gasoline, mababasa po natin or magpipili po tayo ano ba, leaded, ayan po nakalagay, regular leaded, plus leaded, supreme leaded. So, nandyan po yung lead. Kung saan, ini-ignore na lang po ito ng tao dahil kung hindi po gagawa nito, hindi po maging efficient ang pag-function ng makina. So, tinitiis o tinatanggap na lang ng tao, pero sa totoo talaga pong nakakabigay po ng masama sa katawan. Ngayon, kung hindi naman po tayo sa leaded, pwede po tayo doon sa unleaded, pero ang nilalagay naman ay ang bensin naman po. Pakinggan din natin uli kung ano naman ang naidudulot o ano ang explanation dito sa bensin.
Hello, I'm Bob Falco, and I want to show you some important health information that relates to using your car, particularly if you're using a gasoline-fueled car. The issue here is that gasoline, to enable it to run your car effectively, has a percentage of benzene in there that appears to be a small percentage, but could in fact, added over time, turn out to be a health hazard for you. Benzene in particular is related to leukemia, and some other cancers. But the issue here is that it's part of your daily life, and that there are some very simple rules of thumb that can prevent you from building up dangerous amounts of benzene in your system. So, moving right along, let's first want to point out to you that the cancer rates in the United States are incredibly high. This is a little cartoon from Newsweek this past October 2012, which shows that 1 in 2 men will develop cancer. 1 in 3 women will develop cancer. And of those, 1 in 4 will actually die from cancer. Now, the largest source of man-made carcinogens are chemicals that give us cancer, comes from gasoline. It's literally 3/4 of the man-made carcinogens, according to the United States Environmental Protection Agency, that are coming from gasoline. Another 1/8 come from diesel fuel, and another 1/8, the remaining 1/8, come from industry and/or utilities. So gasoline is a major culprit in terms of man-made carcinogens. Now, about 1/3 of the cancer risk in the United States is judged to be due to vehicles. This is a 1999 estimate by the EPA again, from their Technology Transfer Network National Air Toxics Assessment. They're saying that roughly 1/3 of the cancer risk is attributable to mobile sources. That works out to basically 14 Americans in 1 million. You say, well, but we have 300 million people in this country, and 10 million, and that means there's an additional 4,340 deaths every year because of the fuel that we're using in our cars. Okay, the key, there are a number of components of gasoline that are dangerous. There's benzene, there's toluene, there's xylene, for example. But the most dangerous is benzene. Benzene in the fuel we use is first put in at the refinery. Roughly 1%, actually 1.05% on average, has been put in the United States since about 1993. And now there's a move, as we'll see later in this presentation, to lower that amount to 0.62%. But that move's quite complicated, as we'll show. The other way you get benzene is that it is actually created in the catalytic converter. And we'll show you some of the numbers related to this study. While under ordinary conditions, which we'll also show, catalytic converters actually lower the amount of benzene that comes out the tailpipe. Under some conditions, they increase it. Okay, so the thing here that leads the rest of the conversation is that benzene is a major carcinogen. Benzene produces leukemia. And frighteningly enough, there is no agreed upon lower limit of exposure. Now this slide shows you the incredibly wide range that various regulatory agencies have proposed as limits on the amount of benzene that a human can absorb. And most of these are over one's lifetime. So the health numbers literally on the left-hand side of this bar chart are differ by 100 million times. 100 million times. The European Union is that little red line there, and that's their agreed upon limit of benzene. But regulatory agencies in the United States differ by the amount of bars, literally 1,000 times different. On the right-hand side of this chart, this is from the EPA study in January of 2012. What it really means to you and me is that they don't know where to draw the limit from accurate, well-defined statistical scientific experimentation. It's all over the map. We don't know how dangerous benzene is. We do know it's put into our gasoline. Well, don't we have any estimates of this? And the answer is yes, we do. The EPA sets cancer odds, 1 in 10,000, 1 in 100,000, 1 in a million. Let's see what they are. So this is the EPA's odds. Now, bearing in mind that chart, depending on what organization you're drawing your information from, this could be very, very different. But this is our EPA, our Environmental Protection Agency, and so let's have a look at what they say. Well, here's sort of their basis. They say that if you're exposed to 13 to 45 micrograms, that's millionths of a gram, per cubic meter of air, there is a 1 in 10,000 chance of increasing the number of cancer deaths, or I should say, the number of cancer deaths per year will increase by 1 in 10,000. Well, over our population base, that's 30,000 deaths a year. If you are exposed to 1.3 to 4.5 micrograms, in other words, a tenth of the above number, then there's a 1 in 100,000 chance of increased cancer deaths.
So, ayan po, nakikita po natin na ayon po sa data, sa ganito po kadaming micrograms per cubic meter, ayan po, 13 to 45 micrograms per cubic meter, 1 in 10,000. Ganyan po ang naidudulot na sakit sa katawan ng tao sa paggamit ng or sa pagdagdag noong bensin sa gasoline fuel. So, kung gagamitan po natin ito or yung gasoline or yung ating fuel supplement, maglagay po tayo ng supplement na tubig na kung saan sa pamagitan po ng moisture, nakakaiwas po tayo sa mga matitinding sakit. Ito po, umpisahan na po natin ang paggamit sa imbentong gumagamit nga ng tubig, hindi lang po pag-iwas sa mga sakit na yan, kundi nakakatipid pa sa ating pong fuel. Available na po ang device, hybrid po ang ginagawa natin para po doon sa mga gustong gumamit at nakakaunawa po kung gaano ka magandang naitutulong po sa device na ito. At napakagandang accomplishment po natin kung tayo po ay magsama-sama na makakatulong po tayo sa ating pong kalusugan sa pamamagitan ng pag-reduce ng hazardous chemical sa ating pong hangin. Okay, welcome po sa gustong gumamit ng device. Mag-message lang po sa ating pong page na Tubig Fuel Supplement. Salamat po.